All right, so today we're diving into a really wild, almost secretive experiment in AI development from a company called NeuroDelta.ai. Internally, they've got this fascinating code name for it, Willy Wonka. And you know what? Just like the story, it involves a kind of golden ticket and a journey into a world most of us have never seen.
But yeah, we're not talking about a chocolate factory here. We're talking about data. And it all kicks off with this really provocative question. What if you could build a truly game-changing medical AI by training it on the brains of the very engineers and scientists who are building it?
And that's pretty much the whole idea behind their golden ticket. It's this controlled in-house experiment where NeuroDelta.ai is building a one-of-a-kind dataset from MRI scans of its own top people. By keeping it all under one roof, they can move at lightning speed and make sure the data is absolutely pristine.
And get this, we're not talking about some massive anonymous data pool. This is a hand-picked, elite group of just 35 participants. That tiny number makes every single brain scan incredibly important. And the data they get from it, well, it's intensely personal.
So you gotta ask, right? Why go to such extreme lengths? Why turn the microscope inward on your own team? Well, the answer gets to the heart of one of the single biggest problems in medical AI today.
So here's the fundamental issue. You've got black box AI on one side. These things are shockingly accurate, but honestly, we have no idea how they get their answers. It's like magic. Then you have white box AI, which is totally transparent. Now, for a doctor to trust an AI with someone's life, or for the FDA to even think about approving it, you absolutely have to have that white box transparency. The million-dollar question is, how do you get that transparency and the black box performance?
And the specific target they've aimed all this brainpower at is detecting and predicting multiple sclerosis. See, the goal isn't just to make a model that's right. It's to build one that a neurologist can look square in the eye and say, okay, I see why you made that call. I get it. I trust it.
So, how in the world do you force a breakthrough like that? You can't just wish for it. NeuroDelta's answer is something they call the Septem Logic Protocol, and it's basically a 7-way internal race to the finish.
They split those 35 people into 7 independent teams of 5. And this is where it gets really clever. There's built-in conflict. You have Team 1, they're all in on the transparent white box approach. But then you've got Team 3 pushing a pure performance black box model. At the same time, you have other teams working on security, infrastructure, even the financial audit trail for the data. They are intentionally pitting these different philosophies against each other to see what survives.
And the rules for this race are incredibly strict. First, no talking between teams, 0. They want completely independent thinking. Second, and this one is huge, pattern discipline. It means if your AI finds something amazing, but you can't explain the biology behind it, it's a failure. It doesn't count. And third, a weekly pressure test. Yep, a public leaderboard that ranks every team just to keep the competitive fire lit.
Okay, so that still leaves the big question. How can you possibly get the power of a black box and the trust of a white box? Well, this is where we get to the real secret sauce of this whole experiment.
It's this concept they've named Recursive Y Anchoring. Put simply, they use the Y-chromosome as a kind of biological fact-checker. I mean, think about it. It's incredibly stable over generations, so it acts as the perfect, unchanging ground truth. The AI can literally anchor its findings to it, making its entire thought process traceable.
So this is how it works. The AI spots something in an MRI scan that might be an MS lesion. But then, instead of just guessing, it stops and cross-references that exact pixel with the person's genetic data from their Y chromosome. Then it makes a call. If the image and the genetics line up, the signal gets amplified. If not, it gets tossed out as just scanner noise. This isn't just pattern matching, it's biologically verified diagnosis.
So the result of all this is what they call a recursive receipt. It's basically a digital paper trail that explains the why behind every single decision the AI makes, linking it all the way back to the raw image and the genetic code. It's the piece of the puzzle that doctors have been waiting for.
So the technology is just brilliant. But this is the exact moment where the project turns from a fascinating technical puzzle into something deeply, deeply personal and ethical. This is the Crucible. Because every single one of those 35 people whose brains are training this AI has to answer one single, unavoidable question. Do you really want to know what the AI finds in your own scan?
Before the experiment even starts, each person has to lock in their choice from one of 3 tiers. Tier 1 is the safe route. You only see anonymous, group-level data. Tier 2 gets more personal. You see your own individual risk indicators.
But Tier 3, that's the whole shebang. Full prognostic modeling. The AI could, in theory, tell you things about your own neurological future that you can never, ever unknow.
And this isn't just an ethical choice for them, it's a leadership test. There's a quote from the internal project memo that says, "The company believes the people who can confront these kinds of uncomfortable personal truths are the very people who are going to lead the company into the future."
So this incredibly intense personal experiment, it's not just about solving MS or building a new product. It's actually a prototype for a vision that is so much grander. The ultimate mission here is bigger than any one AI model. What they're really doing is prototyping an entirely new way of thinking about our health, what they call a sovereign health system, a system where you, the patient, are finally in charge.
And the core ideas of this system are frankly revolutionary. Just imagine a future where you, not some corporation, actually own your own biological data. A future where you're given the tools to understand your own biology. And maybe most critically, a future where you hold the cryptographic keys to your own health information.
And that's why they keep coming back to that word, crucible. A crucible is where you apply intense heat and pressure to forge something completely new. This whole experiment, with all its technical, competitive, and deeply personal pressures, is designed to do exactly that. To forge not just a new technology, but an entirely new relationship with our own health.
Which, of course, leaves us with a pretty critical question that we all need to start wrestling with. As technologies like this become more and more common, who should ultimately own the intelligence that is created from the data inside your own body? Who gets to own that?